The empirical survival distribution. Suppose a cohort of 5 study units is observed with death occurring at time T1, T2, T3, T4, and T5. Based on this sample data, we wish to estimate the survival distribution applicable to these entities. Bear in mind, we don't really know what is the value of T1, T2, T3, T4, and T5. A very natural approach would be to estimate the operative function of survival St by the observed proportions of the sample surviving to each time point t. You may see it as illustrated in the graph below. We will use S note t to denote this distribution. Value of S note t, which estimate the St, are easily to read from the graph. For all t lesser than t1, the proportion surviving to that t is 1, and we take this as our estimate of St. We take our estimate of St1, which we call is S note t1 to be 0.8. Since we have 5 different intervals and we have the probability of 1, so if we were to divide equally the proportion of each, so your S note t1 would be 0.8. For an initial cohort of size n, this sample estimation approach produces the estimate of S note t equals to 1 for t lesser than t1, n minus I over n for ti lesser than t and lesser than ti plus 1, and S note t equals to 0 for t greater than tn. Bear in mind, for this case, we didn't really know what is the value of T1, T2, T3, T4, and T5. But if you have the data of T1, T2, T3, T4, and T5, you are going to use the data when you estimate the S note t. To some extent, the constancy of S note t for all t between ti and ti plus 1 is not intuitively appealing. We would expect St to be strictly decreasing function of t, and thus our S note t also would be the decreasing function. We recognize that the step-down nature of S note t results from finite sample size from which it was produced. Suppose that the entities under the study here, very few ever survive beyond time t equals to 10. Suppose also that we have a cohort of n equals to 50. So when we have n equals to 50 and we were to divide it equally, the proportions of the proportion for each of the t from interval 0 to 10, you are going to get 0.02 for each death. So for each of the proportions of the time, the step down probability would be 0.02. If we wish, we could revise the S note t, and then you can see it as per shown in the graph below. It is smoother in comparison to the earlier graph. Let's look at these examples. For these examples, you have data for T1, T up until when the persons die. Okay, so in here it was observed at time 3, 4, 5, 5, 7, 10, 10, and 12. And then it asks you to estimate what is S2, S5, and S12. Okay, you can just estimate based on the proportions for this S2, S5, and S12. I leave it for you to try out on this one. The solution is below, but please try it out first before you read the solution. S note t observe the survival functions of the survival patterns observed for the samples to which it relates. As I mentioned just now, it was basing on the data or basing on the proportions that you get for the t. But when you both S note t and S head t, they are estimate value. But S head T is the parametric model with parameters estimated from the data. If you look at the S head T, this one has a smoother curve or smoother line in comparison to S naught T. So distributions usually will give you a better graph or better line than the data. For this case, your S head T is based on the uniformly distributed parametric model. Thank you.